All right, we're going to start with the second part of chapter 7, the IUPAC nomenclature of alkenes. So the rules for naming alkenes is the same as alkanes. You want to find the longest carbon-carbon chain. So recall for an alkane, if we had this, for example, we have 5 carbons and these 5 carbons in a straight continuous line, this would be called pentane. Okay, now the rule is consistent. We need to find our longest carbon-carbon chain for an alkene. Now this alkene will contain a double bond. So let's make a 5 carbon chain, and I'm going to put the double bond right here. Now this is going to be some pentene. Now how I numbered that, notice the ane became ene, and I want to have the lowest number on the double bond. So if I number in this green direction, it gives me 1, 2, 3, 4, 5. So let's say I get to the double bond on carbon 3 first, and that would be 3 pentene. Okay. Now, if I number here in black, 1, 2, 3, 4, 5, I get to the first double bond on number 2. So this would be 2 pentene. So which one is correct? Well, we want the carbon chain to have the double bond which has the lowest possible number. Okay, so the lowest possible number going in both directions, that would give me a 2 instead of 3. So 2 pentene is correct versus 3 pentene. 3 pentene would be incorrect. Now I can write 2 pentene several ways. I can write 2 pentene, or I can write pent dash 2 ene. I can write it that way. These two are equivalent. These two names are exactly the same. Okay, so let's look at a case where we have a substituent. Let's say we have and I'm going to put the double bond here, but I'm going to put a Cl right there. Okay, now let's recall, I'm going to number this in red. If I number this direction, 2, 3, 4, 5, 6, 7, and then I number in green the other direction, 2, 3, 4, 5, 6, 7. So regardless of where the substituent is, I need to have the double bond at the lowest number. Okay? The double bond has to occur at the lowest number. So that means we would have 1, 2, 3, 4, 5, 6. We would have 6 chloro. And 1, 2, 3, 3 heptene, because I have 7 carbons. Or we can name it 6 chloro hept dash 3 dash ENE. Both of these are the exact same compound. Okay? So even though I have added a substituent, we still have to go through the pathway that gives us the double bond at the lowest number. Okay? Now, let's try another example. Let's say I have 2, 3, 4, 5, 6, 7 in that direction. And I have my double bond here, a methyl group here, and a methyl group there. Okay. Now, the same rule would apply. Okay, I want to look at the direction that's going to give me the lowest number on my double bond. So I can see this direction, 1, 2, 3, 4, 5, 6, 7. Okay. So if I highlight this in green, that is your parent chain, and everything that comes off of that chain that's not in green is going to be your substituents. So I have a methyl group here and a methyl group here. So I can name this 3, 6 dimethyl dash 2 heptene, or 3, 6 dimethyl hept 2ENE. I can use that notation. Either or is acceptable. Okay, if we try another one, let's say we have this one. Okay, your parent chain is going to be here, and I want to go the direction that gives me the lowest number on my double bond, so that would be this direction, 2, 3, 4, 5. Okay, so this would be 2 chloro. And since the double bond is on number 1, I can omit the 1-pentene if I wish and just call this pentene. You can say 2 chloro 1 pentene, or you can say 2 chloro pent 1 ene. So all of these are acceptable notations for this molecule. All right. Now, if we do one that's a little bit more if we do another molecule that's a little bit more complicated, it may not be apparent exactly what we have. So let's say if we want to name the following molecule. Let's see, can I make up 1, 2, 3, 4, 5, 6, 7, 8. Double bond there, here, and there. All right, one of these good old test questions. So the same rule applies. We don't want to consider the substituents. We want to consider where we get to the double bond that has the lowest number. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I could highlight that. And that's going to be my parent chain. So my parent chain, I can write out this is 8 carbons. So that's going to be a 3-octene. Okay. Now, what I also have coming off of carbon 3 right here is a methyl. And what I have coming off of carbon 6, you recognize as an ethyl. So all I have to do is put these in alphabetical order. It's the same process as your alkanes. So I would have 6 ethyl dash 3 methyl dash 3 octene. Or I would have 6 ethyl dash 3 methyl oct dash 3 ene. Both of these are exactly the same. Okay. Now, what if we're given a alkene? And I say again, name the following molecule. Okay, so if we're given a CH3 that has 3 CH2 groups bonded to it, that's C doubly bonded to a CH2, and this is bonded to a CH2CH3. How would we name this structure? So what this is a CH3, and I have 3 CH2s. So CH2, CH2, CH2 bonded to this C, which is a CH2, and this C, which is CH2, bonded to a CH3. Okay? So, not to get confused, this represents that, and these 3 CH2s would be represented by this, okay? And this carbon is here, and that CH2 is there, and this CH2, CH3 is the same as this CH2, CH3. So I can count out my carbons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 2, 3, 4, 5, 6, 7. Okay. And here I would have that CH2. So this condensed structure you have to be able to recognize and transpose it into a skeletal. Now, how would I go about naming this? Well, it may not be obvious at first, but I want to get the longest carbon-carbon chain that includes the double bond. So if I count 1, 2, 3, 4, 5, 6. That's a shorter carbon. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this would be 3, 4, 5, 6. Okay, so my longest carbon-carbon chain would be this. Okay? Now, so that's going to be my parent chain. Now, I get to my double bond at the lowest number would be 1 versus 5. So I can say this is 1, 2, 3, 4, 5, 6. So that's 1 hexene. Okay? Now, off of carbon 2, in yellow here, I have an ethyl group. So I have 2 ethyl. So I can name this molecule as 2-ethyl hexene, or 2-ethyl -1, or 2-ethyl hex -1-ENE. Okay, so this format gives the older IUPAC and this last one here is the newer UPAC, but all 3 of them are still acceptable. Okay, Now, when we talk about rings, if we have a ring that contains a double bond, so ring nomenclature for alkenes. Okay, so our ring nomenclature, we want to do the same thing. We want to get to the double bond that's going to give us our lowest number. So instead of, if I use this for example, you recognize this as cyclohexane. Okay, so if I put a double bond somewhere in that ring, this now becomes cyclohex. Now, since there's one double bond in each carbon site is equivalent to another, we can omit the one, or sometimes it can be written as this, or it can be written as one cyclo. Okay. So in this example, we have a methyl group attached to a 5-member ring with a double bond. So to go in the correct numbering order, this gives us the lowest number on our double bond, and it has the methyl group on number 1. Thus it's 1-methylcyclopentene. Here, if we go in this order, 1, 2, 3, that gives us our lowest number on the double bond. If we went in this direction, let's say 1, 2, 3, 4, 5, that would put our substituent on number 5. So we would have 5-methylcyclopentane versus 3, and we want that substituent to have the lowest number on the ring. So thus 3 is the correct name. Now, in addition to rings, we have a situation where we have more in a straight chain. So if you have more than one double bond, let's use this for example. Let's see, 2, 3, 4, okay? Now, 2 double bonds. That is a diene. 3 double bonds. Is a triene. Okay? Now, in this case, if we looked at 4 double bonds, we will have a tetraene. So we're unlikely to see more than 4, but just in case you do, you can see the pattern for naming. So in this diene molecule here, we have to be explicit about where the double bonds are. So we have 4 carbons. So 4 carbons is a bute group. So for a saturated alkane, it would be butane. For this would be butene. So we can call this 1 for this first double bond being on number 1. The second double bond being on number 3. So 1, 3 butyl diene. That would be the correct notation for that. Or you can call this butyl dash 1, 3 dash diene. Both of these notations are correct and they represent the molecule. Okay, let's try another one. All of this is systematic and quite simple. Okay, so we have what? 1, 2, 3, 4, 5, 6, 7, 8 carbons. And I'm going to put a double bond here. Double bond here. And a double bond here. Okay. And in between that, I'm going to put a methyl group there. And a methyl group here. Now, rule applies. We want to get to the first double bond to have the lowest number. So upon visual inspection, we can see that that's going to be our parent chain. Now we number 1, 2, 3, 4, 5, 6, 7, 8. We have 8 carbons, so we're going to have a octa. So we have 8 carbons, and we have 3 double bonds. So that's going to be a octa CTA octatriene. Now, exactly where are those double bonds? What numbers explicitly? So we have double bond starting on 1, double bond starting on 3, double bond starting on 6. So it's going to be 1, 3, 6 dash octatriene. Okay, now we want to look at the substituents, and I want to see I have a methyl here and a methyl there. So it's going to be 4, 5 dimethyl dash 1, 3, 6 octatriene. So I can write that out a little bit clearer. 4, 5 dimethyl dash 1, 3, 6. Okay, so that would be sufficient. Or I could write 4,5 dimethyl octa dash 1,3,6 dash triene. Okay, so both of those notations would correctly represent that molecule. Okay, now what if we have a multiple bond within a ring? The case of multiple double bonds within a ring. Okay, so for example, I can write out this molecule. So we see a 6-member ring, and let me put a double bond here, a double bond here, and let's also put a substituent here and another substituent here. Okay, so where do we start numbering? Let's see. Let's try 1, 2, 3, 4, 5, 6. Let's try the black direction. Okay. And let's try this purple direction. 1, 2, 3, 4, 5, 6. We see that's actually the same as the black. Let's try the red direction. 1, 2, 3, 4, 5, 6. Okay. Seems like we are finding out something there. Let's try a green direction. 1, 2, 3, 4, 5, 6. So this is the systematic approach that you have to take when you are trying to decide what carbons get which numbers, or which carbons get what number, in order to name the molecule correctly. Now, I can see that the green and the red gives me the correct numbering, because it puts me at a 1 for the first double bond and a 4 for the second double bond, and it gives me the substituent lowest number of 3 in the middle. If I go the other directions, it puts me a substituent of 6. So, what I can name this molecule, I have a bromo on number 3. So that's 3 bromo. I have a chloro on number 3. And I have a double bond on 1 and a double bond on 4. So that's going to be 1, 4 cyclo hexadiene. Okay, So all I do is simply put this together. I put alphabetically 3-bromo -3-chloro -1, 4 cyclohexadiene, or 3-bromo 3-chloro cyclohexa-1, 4-diene. Okay. Now, the last topic of conversation, and you can see what I've just told you about multiple bonds here when you follow along with your slides. Our last topic of conversation will be alkenes as substituents. Alkenes as substituents. So, this represents a CH2 group. Okay? So if we have some carbon bonded to this, that's bonded to a CH2, where we had a CH3, which stood for a methyl, this stands for methylene. This stands for methylene. Okay? So in this example, this is carbon 1, 2, 3, 4, 5, 6. Our substituent is methylene, and the parent chain is cyclohexene. Okay? And we also have our vinyl group. The vinyl group is a carbon bonded to the carbon that's bonded to the double bond. Okay, so your vinyl group would be something like that. That would be your vinyl group. And you recognize this to be a CH, and you recognize this to be a CH2. Okay? Now, we see these examples here. And one point I want to make, in order to have a methylene group and to have a, well, for the most part, to have a vinyl group, we must first have a carbon-carbon chain that already contains double bonds. So we must already have a carbon-carbon chain that contains double bonds, because something like this is not considered to be a methylene group. This chain has double bonds, but this is not considered to be a methylene group. Okay, so we need a system that already contains double bonds. So if we look at this system and we say 1, 2, 3, 4, 5, 6, so 2, 3, 4, 5, 6. So we have a double bond between this, and we have a double bond here. And 1, 2, 1, 2, 3, 1, 2, 3. And we have this. Okay? So this would be our parent chain that I have circled in purple. This is carbon 1, 2, 3, 4, 5, 6. Notice that your double bond, your first double bond starts on carbon 1. Second double bond starts on carbon 5. You have 2 double bonds in this long chain. Yes, it is a diene. And the substituent is a vinyl group, a carbon bonded to a CH-CH2 group, just as we have up here. Okay? Now these are very easy to spot once you get the hang of it. Let's try, for example, name the following compounds. Okay, so let's say if we had a ring like this, I'm going to give it that substituent, and I'm going to give it that double bond in the Br. That's one compound, and I find that if we do rings, that these straight chains come easier. So, if I had to name these two compounds, okay? If I numbered 1, 2, 3, 4, 5 that way. Let's see if I number okay. So it seems that whichever direction I number, I get the same thing. So we know we have a cyclic 5-member ring, so that's going to be a cyclo-pentane. Okay. And we have a well, the red is going to give me the more correct. So we have a bromine on number 1. So for the red direction. So I'm going to have 1 bromo. So if I use the black direction, that would give me 2 bromo, but it would still give me the methylene on 4. So I want to use the red direction. So I have a 1 bromo and 4 methylene. So I would name this as 1 bromo dash 4 methylene cyclo CYCLO pentane. Okay, that would be the correct naming, because as I said, if I use the black direction, that would give me the bromo on 2 instead of 1. Okay, now for this structure over here, let's try 2 different numberings. Let's try 1, 2, 3, 4, 5, 6. And let's try one in blue that goes 1, 2, 3, 4, 5, 6. Okay, so going through the double bond in blue, that would put the substituent on carbon 4. And you recognize this as a what, vinyl. And we recognize the ring as a cyclohexane. So that's CYCLOHEXENE. Cyclohexene. And we have a vinyl group on number 4. So it would be 4-vinyl cyclohexene. Or you could write 4-vinyl cyclohex-1-ene. Either notation would be correct. All right. Now this covers naming where the double bond takes priority over a halogen or a alkyl group. So since we have named alcohols, we will pick up next time where the cases where the double bond does not take priority over another functional group that's on the molecule.